Hello everyone, and welcome back to another MAT 170 concept session. Today we're going to be looking at applying a negation to a function. So let's go ahead and get started. Given the question that we have on the screen, we're given two equations, right? F of x and g of x. Now what they want us to do is first off determine the negative f of x and also the negative g of x. So we have negative f of x equals, and then really what we're going to do is just write a negative sign here, and then in parentheses just write the original equation. So we have x plus 5. Now, what we have to do from here is kind of distribute this negative. So think of an equation, right? I'll just write an example as z of x equals x squared plus 5x plus 6. Now, think of really like kind of what this involves is breaking down the equation. So the way you can kind of break down this equation, z of x, is into three chunks: the x squared, the 5x, and the 6. Now, if you notice, the reason why kind of like a good basis to split up your equation is to look at either the plus signs or if there's a minus sign in the equation. Now, what you do is basically back to the original question here with the f of x is you essentially just multiply each part of the equation by -1. So it's going to be the same value that you have or the same variable, but it's going to potentially switch its signs. From here, what we can do is basically multiply this -1 to x and then multiply this -1 to positive 5. Now what that'll give us is negative f of x equals negative x minus 5. Now, say if f of x was x minus 5. If we distributed this negative, we'd have a negative times a negative, right? Which would result in that being positive. So it's really important that you remember that multiplying a negative by a negative results in a positive number, and that still applies in this case. If we go ahead and look for the g of x, we'll go ahead and just do the same exact thing. So we have negative g of x, put our negative sign, and then in parentheses, we have x squared plus 4. And then what we can do is distribute that negative like we did for f of x. So then we'll have negative x squared minus 4. Perfect. Now from here, what we're going to do is graph both of the functions and then kind of look at the relationship between a regular function and then the negation of that function. So we'll go ahead and start with f of x over here first. So we have 1, 2, 3, 4, 5. And then we have negative x minus 5. So from there, we'll go down 5 in the negative direction. And then remember, because we have that negative x, that means our slope is going to be opposite of that to the regular function. The general takeaways from graphing both of these functions is, first off, they are perfect reflections of each other. What that means is that every y value for f of x is the opposite sign of that for the negation of the function. So if we even just taking like off the y-axis, we have 5 here in the y direction, and then -5 down here. So always keep that in mind every time that you're working with regular functions and then the negation of that function. In future sections of this course, you will be looking at like transformations of functions and reflections. So this is a really good kind of primer to that to get you set up for success in that future section. Now we're going to go ahead and graph the g of x equation. So we have our y-intercept of 4. So 1, 2, 3, 4. And then we're going to draw a parabola like that because it's x squared and not regular x. And then we'll graph the negation of that. So we have -4, so 1, 2, 3, 4. And then because it's a negative x squared, it's going to concave down. Perfect. And again, it's the same exact concept. So every y value for positive g of x is going to be negative for negative g of x. Hopefully that was a really good kind of explanation for how to apply a negation to a function. I hope you have a great rest of your day and good luck in your course.